All right, we'll start in a sec. Um, well, Amy and Sarah have heard this. I have to go back to school on Friday. We have a meeting first thing. I have no idea how long it's going to last, so I canceled chemistry on Friday. Probably going to cancel this one just because Lord knows what's going to happen. Who knows if I'm going to be done by 10 the way things go on at school. Your last assignment is posted. Today we're going to just kind of finish the rest of that. Those questions will briefly look at x and y intercepts. Um, where was I going there? Thursday, we'll look at applications of this. Was a couple word problems, some exponential, some log, but it's generally some of the stuff is just, oh, can you write the exponential equation? Can you write the logarithmic equation? The log ones you're probably going to get. Um, and that would be enough for your last assignment. There's a couple of things to go back through that we glanced over earlier. Um, I've got to go back and find a couple things that we skipped over in. A lot of it was word problems, but we'll see where we need to go, what we need to do, how much we need to do going forward. So let's see. Don't want to keep everyone all day. So we did the one logarithms. Most of the time, if there's a single logarithm, you're going to write it in terms of the exponential form and go through. It's when you have two logarithms that things are a little bit trickier. If they have the same base, you can quote unquote cancel the base. Um, eliminate or evaluate is the second trick, which I kind of missed in one of them. So these ones are all quote unquote cancel, which is really raising everything to that power. This one, we have a 1 here. I'm going to do a little bit of conversion there. Log base 2 of 4, log base 5 of 25. Um, that one we're going to combine some stuff. I'm actually going to do 5 and 6 first, and then look at 7 and 8, and then go back to this one because that one is a little bit special. And then that should give you enough to do all of the questions in here. I'll go through tomorrow probably and look at answers, putting up answers for those to give you a chance. Where in the world am I? All right. Log of 4x equals log base 2 of 4. Oh my gosh, this is oops, base 10. This is base 2. But we need to, the kind of trick, 2 to what power equals 4? Well, 2 squared equals 4. Log base 10 of 4x equals 2. 10 to the power of that, 10 to the power of that. Those cancel. 4x equals, whoa, not 100. 10 squared, not 1,000, sorry. 10 squared is 100. Divided by 4 equals, x equals 25. 4 times 25 is 100. Log base 10 of that is 2. And that is 2. So we're kind of there. That's kind of straightforward. Same idea over here. Log base 5 of 25 is 2. Log base 3 of 2 to the x minus 1 equals 2. Raise it. Those are the exponents. 3 squared is 9. Those go away. 2x minus 1 equals 9. Now we have a grade 8 or 9 math problem. Add 1. Add 1. 2x equals 10. And x equals 5. So far, so good. The two logs on the same side. Whoops. Apparently I've done something. It went too far. Now let's see. Can I erase that cross line? Use the law of logarithms to make them one logarithm. We've done stuff with the power one, but we can use the sum product one. If I have the sum of log base 7 of x and log base 7 of 5, that is going to equal, if I knew how to write, log base 7 of 5x, log base 7 of 7. Those go away. 7 to that power. So 5x equals 7. Where am I? Because that equals 1. Oh. Well, it's gonna be the same thing regardless, because we would raise that to the 7. Those go away. If I make that 1, it's just 7 to the 1. 5x equals that. X equals 7 over 5. Ooh, this one's going to be, oh, no, log of 30 divided by 2, 5x. So this is log of So I'm going to rewrite this. 10 to the 5x equals 15. Am I just doing this around in circles? Log both sides. Yeah, this is just going to be circular. That comes down. Yeah, so that's not going to make any sense. This one, I think. Whoa. Well, the log of 15. Divide that by 5. And that is the end of that one. Because there's no other way we can combine that. That's just a number. Now, this one here where we have a 1. Well, I can combine this. Log of 2 times x minus 5 equals 1. 10 to that, 10 to that. Those go away. 2 on 2, x minus 5 equals 10 to the 1 is 10. 2x minus 10 equals 10. 2x equals 20. X equals 10. 10 minus 5 is 5. 5 times 2 is 10. The log of 10 is 1. And that everything all makes sense. So those are just some examples of those. That should give you enough to do all of this. So we glossed over x and y intercepts for transformed exponential and logarithmic functions. For a base exponential function that's growth, we're going to have a y-intercept where x is 0. For a logarithmic function, we're going to have an x-intercept or an x-intercept where y is 0 because it's just an inverse. But when it's transformed, we actually can have both. So we can use the skills that we've gained to figure these sorts of things out. To find a y-intercept, we set x equal to 0. So y equals 2 to the 3, 2 times 3 to the 0 minus 5 minus 8. Can we solve this equation? Y equals 2 times, well, 0 minus 3, 0 minus 5 is negative 5 minus 8. Oh, that's going to be 2. So 3 to the negative 5 is 1 over 3 to the 5th minus 8. Order of operations. 3, 9, 27, 81, 3 eighths are 241. 2 times 1 over 2 over minus 8. Oh, now I need to break out my handy dandy calculator. I'll move that over here. 8 times 2, 43. 2 over 2, 43 minus 2 minus 2 minus 944 is we have an x-intercept of 0 and negative. You want to be particular, you can do that. You can subtract this. That would have an x-intercept of negative 7.99. This is another way to graph some of these, because if you have your x and your y-intercept and you know where your asymptotes are, you can plot these. To find a y-intercept, or an x-intercept, sorry, we let y equal to 0 equals 2 minus 8. Can I solve that? I'm going to move the 8 over. Divide the 2. 4 equals 3 to the power of x minus 5. Well, when we have one of these, log, log, log of 4 equals log of 3 to the x minus 5. The power law moves that down. Log 4 divided by log 3. I'm going to evaluate that bit now. Oh, that's bad. 4 log divided by 3 log equals our x-intercept, add 5, 6.26. So the ordered pair here is 6.26 and 0. So we know the y-intercept is 0 and negative 7. The x-intercept is 6.26 and 0. And our graph would look something like that. The asymptote is at minus 8. And there's, without having to generate points, same idea with logs. And once we do these two, we'll kind of finish. Well, let's do it in a different color for fun. y equals 2 log base 5. Let x equal 0. So 0 plus 3 plus 1. 2 log of 3 plus 1. Move that up. Oh, log base. Da, 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 da. Log base 5 of 3 squared plus 1. Log base 5 of 9. Well, I can evaluate this by doing, not LG, I'm not talking about a tech company, log of 9 over log of 5 plus 1 equals something plus 1. So this is our y-intercept. So that point is 0 and 2.37. X-intercept, let y equal 0. Let's find the original equation. Oh, 2 log base 5 x plus 3 plus 1. Oh yeah, that's gonna work. X plus 3 divided by 2. Why am I getting like 19 emails right now? Oh. 5 to the power, 5 to the power of that goes away. X plus 3. 5 to the negative 1/2 is 1 over the square root of 5. So that's going to be kind of messy. Well, that's 1 over root 5. We can evaluate that now. The square root of 5, take 1 over it. Is x plus 3. 0.44 minus that is like 2.36. So we have those 2 points. A logarithmic function. Negative 2.56 and 0. So I've totally messed something up. 0 and 2.37. Oh yeah, this is a horizontal asymptote at negative 3. And our graph would look something like that. So it's just an alternative way, same idea as when we did graphing quadratics and foundations. We can do it with a table of values. And then we learned that we could find our intercepts. Intercepts are important. This is a skill that would come in handy in calculus. Okay, I need to know where my intercepts are because those have special things with calculus, and we can sketch our graph. We'll talk about those a little bit more probably next week. We'll look at some word problems on Thursday, and we can practice those sorts of things today if you have time or the wherewithal or the need. So that's where I'm going to stop today. Check out the assignment. And that's about it. Unless there's any questions, I'll sign off. Go enjoy the sun before it rains tomorrow.
Mr. McKay,
Yes.
so that was the last, this is our last assignment for
Yep.
this class?
Yep.
Thank you.
Welcome. Adios.
Bye. Thank you.
Bye. You're welcome.